In this video, I am going to show you how to find the probability distribution function of a continuous random variable. Okay. So let's go slowly here because this is a pretty elaborate procedure, so you may have to do it a few times before it begins to settle down and doesn't seem so intimidating. Okay, but you've got to just be patient with yourself when you see a procedure of this kind for the very first time. Let's take a look at what we have. We are given the following probability density function. Little f of x equals 1/2 x, and this goes between 0 and 2, and it's 0 otherwise. Okay, so this is our PDF, our probability density function. Now the question is, find the probability distribution function. So those are different words meaning different concepts. Okay. So as in the case of a discrete random variable, we need something that accumulates the probability. So because this is the continuous version, we use an integral. Okay, so what you may want to write in general is the following. Big F of x is the probability that the random variable assumes a value less than or equal to little x. And in terms of an operational definition, something can actually operate on to get something out. It's an integral from -infinity up to this value of x here. Okay, there we are. And here, because we're using x as a limit of integration, when you write these, it's common practice to use u as the variable, as a dummy variable. Okay, so one more time. What you are given is the probability density function. You have to find the probability distribution function of this variable, continuous random variable. So use the letter big F equals the probability that big X, okay, the random variable, is less than or equal to little x. That's a specific value of big X. That's an integral from -infinity up to little x of f. And we have replaced the variable x with u because we are using x here as the limit of integration, the upper limit of integration. So let's take a look. First, let's take a look at some pictures to be sure what we derive we can interpret graphically so it's more meaningful to us. Let's first sketch the PDF. So we draw the coordinate system as always and label everything in convenient units. Okay, this is our x, and we're going to sketch little f, not big F, little f. So here, every two spaces will be 1. Okay, there we are. So 1/2 of x means the following: 2 to the right and 1 up. And then this function is defined only between 0 and 2. So what it does is that it looks like this, you see? That's our PDF, our probability density function. Well, with this in place, the next step is to find the probability distribution function. And here I may want to put a hole here, but okay. So now the question is, what do we do from here? Well, we've got to accumulate the area under the curve. So the first step is do this. Break the regions of integration into 3 pieces. Everything to the left of 0, between 0 and 2, and then from 2 up to positive infinity. Okay, so let's go through that procedure. Let me grab a Sharpie. So from negative infinity up to 0, 1/2 x dx is 0, right? So in other words, I am integrating 0. And the integral of 0 is still 0. Then, between 0 and some value of x restricted to the interval 0 to 2, I have the following. I use the 1/2 x dx. So let's perform this integration. So the 1/2 goes out. Use the power rule on x. So that's 1/2 of x squared between an upper value of x and a lower value of 0. This gives 1/4 of x squared minus 0 squared. So that gives 1/4 of x squared. And this, you could say, lies between 0 and 2. Okay? So this is the probability distribution function between 0 and 2. And the last one, of course, is from everything accumulated, right? Everything that can possibly be accumulated. So that's everything from negative infinity up to 0, from 0 up to 2, and then from 2 all the way to positive infinity. Okay, so that breaks up into 3 integrals. Negative infinity to 0, but that's 0, so that's nothing. Plus 0 to 2, but that's 1/2 of x dx, plus 2 to positive infinity, but that's once again 0. So of these 3 integrals, this one is 0, this one is 0, and all that remains is the integral between 0 and 2 of 1/2 x dx. And you know that because this is a PDF, it's got to be equal to 1. Okay? So now that we've kind of, we've gone through the various regions of integration, getting a 0 for everything from negative infinity up to 0. Then we got 1/4 of x squared between 0 and 2. And then lastly, everything, so to speak, from negative infinity to positive infinity, that's equal to 1. Once we have these facts, we can now write down the following. Big F of x, the probability distribution function, is given by the following. 0 for x less than 0. It's 1/4 of x squared for 0 less than or equal to x less than 2. And then it's 1 for x is greater than or equal to 2. Okay? So this is the probability distribution function of this probability density function. So this is an elaborate procedure. When you first see it, I suggest you do it a few times, watch the video until it begins to, seem a little less involved. But to review, you're given a PDF as follows. The fundamental concept is to get the probability distribution function from the probability density function. You set up this general concept here. So it's the area accumulated between negative infinity and x. That's what this integral represents. Of course, that's the geometric interpretation. It's also the probability that is accumulated. Here's a picture of the PDF. So first we integrate between negative infinity and 0, we get nothing. Then we integrate between 0 and some value of x that lies within the interval 0, 2, such as this value of x here. So from that we get 1/4 of x squared, and this applies between 0 and 2 as shown here. And maybe, okay. And the last one is add up all of the areas. So everything from negative infinity to positive infinity, but that's equal to 1, because this is a probability density function. Okay, that's equal to 1. So now you can write big F, the probability distribution function, as this. Okay? And now let's use the probability distribution function. What use do we actually make of this function? What it allows us to do is calculate such things as follows. To say the probability that 1 is less than or equal to x, which is less than or equal to 2. If you were to find this using the probability distribution function, you would write big F of 2 minus big F of 1. Okay? That's how you would actually use it in practice. So in our case, it would be big F of 2, which is, as you can tell, 1. Big F of little 1 is 1/4 of 1 squared, which is 1/4. And of course, 1 minus 1/4 is 3/4. There we are. Okay, so the probability that x lies between 1 and 2 is 3/4. And then in the previous video, I did this only with the probability density function, and the result was the same. Thank you for watching, and I suggest that, if you're doing this for the first time, take your time, do it a couple times, do it a few times, do it as many times as necessary for you to understand this concept. When you first see it, it seems elaborate, but you do it 5 or 6 times, it becomes almost mechanical. Okay? So, thank you for watching and taking the time to watch this video and study this amazing subject. My name is Tom, and have an absolutely amazing day.